So we're going to start with probability, and I'm going to give you guys a chance to read through this first question over here. And it's going to involve Venn diagrams, which we normally really appreciate. Okay, I want you guys to read through the question 8.1, 8.1.1, and 8.1.2. I'm going to ask you guys to stop there. And then once you're done reading it, I want you guys to pop your glasses, nerdy glass dude emoji in the chat, just so that's okay, Kamogelo. We're going to try and go a little bit slower for you so that you can understand where we're coming from. Okay, I will try my best to slow it down. But once you are done, reading the question, put your emoji in the chat. Thank you, Keegan. Bundle, what's going on, my sweetie? I see your hand is up. What's up?
Hi, ma'am. How are you?
Hello. I'm excellent, thank you. How are you?
I'm good. I just wanted to ask that what will be the topics that we will be focusing on for this coming term 4?
That is a very good question. All right, so we're going to start with measurement on Monday. And then after that, we're going to do number pattern. And we will then have finished the whole grade 10 syllabus. So we're going to go back to the beginning and do a year-end revision. Okay, so just measurement and number patterns left. Okay.
Okay, ma'am. Thank you.
So once we're done with that, we're going to start revising from the very beginning. All right. Very good question, by the way. I love it.
Thank you, ma'am.
You're very welcome. All right, I can hear somebody else is unmuted. I'm going to ask everybody to mute for me, please. Make sure that you aren't unmuted as we're speaking, because we just need to keep the quiet of the room. Yes, Oratile, I will. I'll remind you guys again. Okay, on Monday, I'll remind you guys again. All right, I'm seeing enough glasses emoji for us to get started on today's lesson. So let's see. Okay, so the question over here says, let's read from the very beginning. Remember, guys, the first thing we always do when we get a question is we read. We start here. Always, always, always start by reading. Right, it says, at a certain school, there are 64 boys in grade 10. Right, so what do we call the 64, guys? What is that 64 actually called? Our what? The word starts with an S. Give you guys a hint. Correct. It's our sample space. Well done. That's it. It's our sample space. Or we can also call it our sample size because we're looking at 64 boys. So excellent. This is going to be S is equal to 64. Sample space. Well done. All right. Now, there are only 64 boys. So we know that we've got boys that play soccer and boys that play rugby. Right, so how many circles do I need to draw in this particular case? Correct, we're going to draw 2 circles. We're going to make sure they fit. Okay. Right, excellent. Okay, so we're going to put the 2 of them like that, right? Okay, and you will notice that I'm making my circles overlap. Why do I make my circles intersect? Okay, and I'm loving some of you guys are saying 2 intersecting circles. I love that. That's very specific and it's a good specific. Leah, I need you to explain to us why we want them to intersect. Okay, Isayan, what happened? Correct, Sinogushe, beautiful, that's it. That is it, good. It's because they play both sports, well done. So where they intersect, okay, or where they have something in common, beautiful. And what do we call it because there's 2 different terminologies, okay, 2 different terminologies. They're saying that we've got 10 boys play soccer and soccer or. What is the difference between and or? Correct. One of them is a union, one of them is something else. Which one is the union? Correct, Naledi. Which one is the union and which one is the intersection? Let's talk. Which is the union, the and or the or? The and or the or. Correct. The union is correct. The union is or, this is union, and is the intersection. Ah, I'm loving this. And not is the complement. Okay. The not is the complement. All right, so let's see what they say here. They say 24 boys play soccer. So we know that the whole of soccer must equal 24. We know that 28 boys play rugby. So the whole of these boys need to play rugby, right? No worries, Amachelang, you're very welcome. See, ma'am is like on point with those things. Right, now it says 10 boys play both soccer and rugby. Where does this 10 go, peeps? Where do I put this 10 that says soccer and rugby? Correct, Isayan, beautiful. In the intersection, in the middle. Good, so we know that we've got 10 over here. Right, we've got 10 in the middle. Right, then it says 22 boys do not play soccer or rugby. Where does that 22 go? Outside, okay, there, 22. There, it's outside. Outside, no, Mfundo's like, no, that's not outside. Correct, in the box, but outside of the circles, correct. So here, 22 over here, outside of the circles, but in the sample space. Well done. That's it, Nicole. I love how Nicole using the right English, man. She's using the right English. I like it. Okay. 22 was kicked out of the classroom. Amogelang, behave. Behave. All right. Good. All right. So let's fill in the rest of this, because this part over here and this part over here are still missing. So let's fill that in. Right. Now it says here that 28 boys play rugby. But what do we notice? Anybody want to venture and put their hand up and tell us what's actually happening inside that rugby equals 28? Yes, Anotida.
Hi.
Hello.
Well, how are you?
I'm good, thank you. How are you?
I'm good. Well, okay, so that 28 is going to be subtracted by 10.
Beautiful, good. We're going to subtract 10 because the whole circle must be 28. So how much goes in the rugby only section?
18.
Correct, 18, correct. And what happens in the soccer only section? What do we put there?
Only. We do the same thing. You say 24 minus 10 and you get 14.
Beautiful. Ah, you see, this is why the people, they trust you. Guy, you're going to lead us to the promised land. I mean, that's why. Every time you have to answer a question, everybody's like, yeah, he's got this. It's because you actually do, dude. Well done. Very nicely done. Okay. Excellent. Excellent. But a head boy. I love it. I feel like Anno should, guys. Whichever school Anno goes to, we need to go speak to the principal, guys. Anno must be head boy. I refuse. Yes, that is our motto. In Anno we trust. Yes, I love it. Okay, cool. So we've done this. We have represented this in a Venn diagram. Now I want you guys to tell me. Good. You have our vote, guy. He's like, I'm fighting for that. Okay. Keegan says 22 plus 18 plus 14 is equal to 52 though. But Keegan, what have you missed? 54. Which one did you not add? Which number did you not add? Correct. Abigail. Yes, that's it, Rulani. Correct. Where is the 10? You've forgotten to add the 10 together, Keegan, and all of it together must give us 64. I just want to see, no worries. Okay, so I'm going to ask you guys now, give me a thumbs up in the chat if you understand how we've put our Venn diagram together and if your Venn diagram would look like mine. Okay, give me a thumbs up if you're okay with how we've drawn the Venn diagram. If not, you're more than happy. Put a thumbs down because I don't want to leave you behind. This is an important section. Okay, for those of you with your thumbs up, I want you to go ahead and answer question 8.1.2 and 8.1.3. And we're going to talk about each of these. All right, Unati, what's up?
Hello, ma'am.
Hello, my sweetie, what's going on?
Ma'am, I have a question. You see, for the,
Yes.
like, how did we get to the 18 and the 14 in the circles?
Okay. All right. So the question over here says to us that 10 boys, they like both soccer and rugby. So you agree that this 10 needs to go in the middle. Yes?
Yes. Yes, ma'am.
Good. Right. Excellent. But now they're telling us, they're telling us, Unati, that 28 boys play rugby, right? So if 28 boys all together play rugby, we've already counted the 10 in the middle. So how many are left that we haven't counted? Am I making sense?
18. Okay, I get it, ma'am.
Correct. Got it. Same
Yes.
with soccer. We're going to have the same problem with soccer. If 10 of them have already been counted, how many of them are left that play soccer? 14. All right.
14. Yes, ma'am. Thank you.
You're very welcome, my sweetie. Good. Keep those questions coming. All right, let's talk about the probability. Now, we need to remember, guys, that when we're calculating for the probability is going to be the event size divided by the sample size. Okay, and we know our sample size. Our sample size is 64. So we just need to find the event. So I'm going to give everybody a couple more minutes, like 2 more minutes, and then we're going to talk about we're going to talk about the answers that we're looking for here. Sure. Pamela, how are you doing? I work with another teacher here named Pamela. She's very elegant. I feel like you'd also be one of these. Hi, Pamela.
Hi, ma'am. Ma'am, I just
What's
wanted
up?
to answer the question when everyone is done working it out.
I love it. Yes, keep your hand up. I'm going to unmute you in just a little bit and then you can answer for me. Okay. I'm getting a lot of emojis already, so I'm assuming that we're all doing great. We're doing great. And I'm a little worried about what is going on here. Because my charger is not charging, and I'm not 100% sure what I'm going to do about it. Oh no. Oh no. Okay, I'm gonna have to figure out a plan. I might have to move. Okay. All right, peeps. Okay, let's get started. Okay, Pamela, let's talk about the first one. Right, it says here, calculate the probability that a grade 10 student chosen at random, selected at random, plays soccer and rugby, right? So we're looking for the probability. Again, if I say soccer, how do I express and? What is the symbol for and, Pamela?
Ma'am, that rainbow thing is not smiling, it's sad.
Correct, it's the intersection, correct. Yes, the soccer intersection with rugby, correct. It's the rainbow, the sad one, correct. So what is the probability that we choose soccer and rugby? What is the intersection?
10/64.
Correct, 10/64, but we must always simplify. Okay, so
It's
10/64
5/32.
simplifies. Beautifully done, that's it, 5/32. Wonderful, we're off to an amazing start. All right, let's talk about soccer or rugby. What is or? If I wanted the probability of soccer, how do I express or?
It's the union.
Correct, soccer union with rugby, right? Which is equal to, let's talk about this.
42/64.
What is the union of soccer? Correct. So it's going to be 18 plus 10 plus 14, which will give us 42 over 64, which translates to
21 over 32.
21 over 32. Beautifully done. Okay, excellent. Very, very nicely done. Do you think you're going to be able to answer the last question for me as well?
Yes, ma'am.
Beautiful, excellent. All right, let's talk about this. Are the events a grade 10 boy plays soccer at the school and a grade 10 boy plays rugby at the school mutually exclusive? Yes or no?
Yes.
Okay, why do we say yes?
Ma'am, I think because there's something in common.
Okay, but remember, exclusive. What does exclusive mean? Even if we just look at the word
Ma'am,
exclusive, like the
separate.
they're separate, exactly. We're excluding them from each other. Okay, I'll go through it again. All right, so but if we look at our Venn diagram, does soccer and rugby have something in common?
No. Oh, yes, yes.
Oh, do they
yes,
not?
Yes,
Yes, they
yes,
do. They
ma'am.
have 10 players in common. So are they mutually exclusive?
No.
No, they're not, right? And the reason we can say that is because the probability of S intersection with R is not equal to 0. Because the probability of them together is not equal to 0, then it's not mutually exclusive. It's only mutually exclusive if they don't have anything in common. Does that make sense, Pamela?
Yes, ma'am.
Beautifully. Like, I'm just so happy you've done that so wonderfully and you've gotten every single answer I'm looking for. Well done. Very
Thank you,
nicely
ma'am.
done. I love it. Excellent. I love, love, love it. Guys, keep those hands coming. I want to hear your opinions. All right. I see somebody saying, please explain 8.1.2b again. Absolutely. All right. So remember, guys, the union, right? The union is going to be if you play rugby or you play soccer or you play both, right? So it's going to be the rugby players and the soccer players and those who play both. Now, if I add all three of these together, I get 42, right? But it's 42. Okay, it can't be 22 because these people don't play anything. They don't play any sport, right? So we can't use them. The 22 doesn't play any of the sports. Over here, they want to know whether you play rugby or soccer or both. So in that case, how many of us play rugby or soccer or both? 42 out of how many? Out of 64. And if we make that easier, if we simplify that, that's going to give us 21 over 32. I need you guys to give me a thumbs up if my explanation makes sense. Yes, correct, Oradilwe. Everything that has anything to do with soccer and rugby, add them together. Soccer or rugby, all of it together. Okay, excellent. All right, beautiful stuff. Let's move. Let's keep moving. Okay, let's keep moving. Let's look at this next question over here. It's going to be a bit of a doozy. So, okay, I'm going to do that. While I'm doing that, while I'm explaining, I want the rest of you guys to have a look at 8.2 and 8.3. Okay. And while we're doing that, I'm going to quickly explain to Reabetswe what we mean by mutually exclusive, right? So, and for those of you who are not 100% sure about mutually exclusive, let's listen up. All right, so let's say, for instance, I'm going to toss a coin. If I toss a coin, Reabetswe, answer me in the chat, and if you're listening along, you can also answer me in the chat. What are my two options? What is my sample space? What can I possibly get if I flip a coin? What are my possible outcomes on a fair coin? Correct, Lulu, beautiful. Heads or tails, right? Heads or tails, excellent. Now, think about this. what is the probability of me getting heads? What is the probability of me throwing my coin and getting heads? Correct, 50%. Excellent, that's it, 50% or 1 out of 2, because I have 2 options, right? The probability of me throwing tails is also 1 out of 2. Now, think about this. What is my probability of me throwing heads and tails at the same time? What's the probability of that happening? 0, correct, 0. It can't happen. I can't have heads and tails at the same time. It's not going to happen. So if I get heads, if I toss my coin and I get heads, that excludes tails. And if I toss my coin and I get tails, that is going to then exclude heads. Only one coin, Entle. Don't start. No, we're not going to start different novels now. One coin. One coin. Right. So these 2 things are mutually exclusive because they can't happen at the same time. Right. But now if we look at the example that we had above, if I play rugby, does that mean that I can't play soccer? Does that mean that I can't play soccer? No, I can. I can play both of them together. So are these 2 events, are the events playing soccer and playing rugby mutually exclusive? No, they're not. And the reason for that is because I can do both of them at the same time. I can do both of them at the same time. That's why we have the intersection. As soon as we have an intersection, then it's no longer mutually exclusive. Give me a thumbs up for those of you who are a bit confused, whether this makes sense. All right. Okay. Excellent. I'm getting 1 thumbs up. I'm going to assume everybody else. Okay, great. Excellent, Rabbit, because I'm like, I've only got 1 thumbs up. I'm a little bit worried now. Vasha just gave me a foot. I don't know what to... Yes, correct, Mfundo. It's like, in fact, most things, if we think about it, if I can't be at Paris, I can't be in Paris and in Berlin and in Budapest at the same time. I can't be in all 3 places at the same time. I can only be in one place. So all 3 of those events are mutually exclusive. Okay, correct, beautifully said. All right, let's look at the next questions that we've got. I'm going to give you guys 3 minutes. No, we don't count digitally, no. Anatita, stop writing stories. No novels. They can't happen at the same time. Okay, I'm going to give you guys 3 minutes to answer questions 8.2 and 8.3. Pop your answer in the chat when you are ready. Okay. Dig Italy. Mawande, focus. Mawande, focus. Siamtanda, are we already done, or are we just putting the Portuguese flag in the chat for Justin J for vibes? One more minute, peeps. Sure, Teacher Nelly. That's okay, Princess, welcome. Do you know what I'm gonna need from you, Teacher Nels? Because the plug where I'm sitting isn't working. The plug is not working. So as soon as I'm done and you put the link to the quiz in the chat, I'm gonna run away. Okay, just so I can find another place where there's a plug, possibly plug my computer. All right. Okay, I think that's enough time, guys. Let's start looking at this question. All right, so the question says here, one morning, Samuel conducted a survey in his residential area to establish how many passengers, excluding the driver, travel in a car. The results are shown in the table below. Right, so it says here, calculate the probability that, excluding the driver, there are more than 2 passengers in a car. Now, in order for us to calculate the probability of anything, we're going to need 2 things. The first thing we're going to need is the sample size, and we're going to need the event size. Rulani, how's it going, my sweetie? Hello, Rulani.
Hello, ma'am.
Hello.
Ma'am, I'm just this question. Can I do it? I don't know if it's correct, but I want.
Absolutely. Okay, go for it. Go for it. Okay.
Ma'am.
All right.
So
Let's start with the sample size, Rulani.
For me, I added all the number of cars together.
Beautiful. And how much did we get?
I got 30.
Excellent. So we know that our sample size is equal to 30. Good. Now, let's think about the event. They say that they want us to calculate the probability, right? The event size, that there are more than 2 passengers in a car. So how many people are there that have more than 2 passengers in a car?
Ma'am, I added 4 and 3 because those are the only passengers that were more than 2.
Not quite. Not quite. Okay, think about this. Think about this. Okay, we've got that. Okay, 3 and 4. Remember, we're not looking at the number of passengers because this is independent information. We've picked this. How many students altogether have actually, or how many passengers altogether have actually opted in here?
6.
Okay, how many of them have more than 2? Correct. 6 cars. Correct. 6 cars. And I think we might not be reading this question correctly, which is why it's worth 3 marks. Good. All right. So if I had to find the probability that there were more than 2 passengers, what would that then be?
It's gonna be the 6 divided by 30.
Correct. 6 over 30. And if we simplify that, that's going to be
0.2.
correct. 0.2 or 1 over 5, right? Or 1 over 5. I want us, okay, Rulani, you've done this absolutely correctly. I just want us to explore a different option, right? I want us to compare a different option, and I just want to see if my thinking behind this might be a bit off, right? So let's think about it. If we think about the number of cars that don't have any passengers, right?
Yes, sir.
That means that means these 7 people, or this number of cars, right, is actually 7 people, correct? 7 drivers. Agree?
Yes.
Good. So the question says here that we are not to include the driver, excluding driver. So are we then going to still include these 7 people? And this is me trying to rationalize this. Rationalize this in my head. Rulani, can I mute you for just a second, my sweetie? I need to just rationalize what's happening here. Teacher Nels, help me out. I hope I'm not misreading the question.
I feel
right?
like they already said
Because
that he excluded the driver, which means that's the number of passengers.
okay, but how many cars had 0 passengers? 7 of them. Right? So he's already excluded, they've already excluded the drivers. Okay, excellent. Here's my second question, Teacher Nels, right? If we had to count the probability excluding the driver that there are more than 2 passengers, Okay, yes. So we've done this question correctly. Because in my head, I was thinking, if there's one passenger in 11 cars, that's 11 people. You understand? And if there are 2 passengers in 6 cars, that's 12 people. You see where I'm going with that? If there are 3 passengers in 5 cars, that's 15 people. And if there are 4 passengers in 1 car, that's 4 people. And then altogether, we'd have to add up how many people that is. But that's not what the question is saying. It's saying that, okay, what is the probability that there are more than 2 passengers in a car? So we're not really focused on how many people, we just focused on the probability of that particular car having more than 2 people in it. So yes, Rulani did answer this question correctly. Okay, Amgelan, can you not hear me? Can I just double check with everybody? Give me a thumbs up if you can hear me, because it seems like some of y'all are having issues. Correct. Who said that? Who said favorable outcomes over number of outcomes? That's it. That's it, Leah. That's what we're looking for. Excellent. Okay. Yeah, I think you guys understand this a little bit better than I do at this moment, because I'm now confusing myself. All right, let's look at 8.3. It says, if you throw 2 dice at the same time, right, the probability that a 6 will be shown on one of the dice is 10 out of 36. And the probability that a 6 will be shown on both the dice is 1 over 36. What is the probability that a 6 will not show on either dice when you throw 2 dice at the same time? Oh, I see, Andre, I see. I don't think it's my connection, though. My connection is pretty okay. All right, okay, so who wants to venture and help us out with this particular question? Because we need to think about this. Who's got a possible answer for me here? Let's think about this. Anybody got any ideas? Where can we start? Okay, let's think about the not. Okay, correct, Leah. That is it. Good. What do we know about not? What is not? What is not? What are we talking about when we think of the not part of it? Correct. It's the complement. Excellent. So we know that we're actually looking for the complement, right? So the question is telling us that what we're going to get is the complement of these answers that we have. I know she's on fire. She's on fire, right? So if we think about this, they are telling us, oh my goodness, my computer's going to die. Okay, I'm gonna have to move, and as in now. Let me see how much longer I have. I've got 13 minutes. Hopefully my computer doesn't die on me. All right, so if the probability of getting 6 showing on one of the dice is 10,6, what is the probability of not getting a 6? If the probability of getting a 6 is 10 over 36, what is the probability of not getting a 6? Apiwe. Hi, Apiwe. Correct. But for those of you who are saying 26, it's not just 26. It is going to be. Hello, Matindi. Can you tell me what is the probability that I'm not going to get a 6? Okay, I've lost a P-way. I don't know what's happened. It's going to be 26 over 36. Is everybody with me here? Okay, then it says, okay, and the probability that a 6 will be shown on both dice. Okay, I just want to make sure I'm reading this question correctly. Yes, Sinogutle, you're onto something 100%. Okay, so the probability that we get So the probability that we get a 6 on both dice. So a 6 and then a 6 is 1/6. What is the probability that we do not get a 6 and then a 6? I'm wondering where all these numbers are coming from. Oh, yes, 13, yes, 13/18. Okay, we'll get to that in just a little bit, Mawande. I know you're simplifying. We'll get to that. All right, guys. So if the probability of getting a 6 and then a 6 is 1/6, what is the probability of not getting a 6 and then a 6? Good, correct. Elife, remember, you can't just say 5, okay? You need to say 5/6 because it's the probability that we're looking for. Okay, good, 5/6. Now, the idea of not, and Leah has already kind of told us what we are looking for here, because the idea of having not means that we need to take both the probabilities and they must give us 1, right? So if the probability of throwing a 6 is going to be 1/6, the probability of not getting a 6 is going to be 1 minus 1/6, which is where we get the 5/6 from, right? So I'm now just realizing, oh, sorry, this is 1/36. I'm sorry, guys. I'm the one who's lying here. This is 1/36. My apologies. The question literally says 1/36, guys. So the answer that we're going to get over here is not 5/6. It's going to be 35/36. And I saw somebody say 35/36. I'm the one who didn't exactly see where it was coming from. Sorry, Ritumeti. Like in my mind, it made perfect sense. No worries, Jonathan. Thank you for joining us today. All right. So again, guys, if we want the probability of not something, okay, we're going to take 1 minus the probability of the thing that we want. Okay, the probability of the event itself. Now, because we want not, we've got that as not. No, this is not. If we want not, we're going to take the actual probability and the actual probability over here and minus it from 1. Okay, so to find the probability of not getting either of those, we're going to say the probability of not 6s on both dice. We're going to say that's 1 minus, and we're going to put in the probability of 6 and the probability of 6/6. So 10/36 plus 1/36. Okay, I need somebody to punch that into a calculator for me and give me an answer. 1 minus 11/36 should give us, I think I saw somebody write the answer. I think the answer is 25/36. 25/36, correct.